Hello and welcome to Giving Away the Keys to the Kingdom using Terraform to automate Databricks. My name is Hamilton Horde, and I'm a site reliability engineer at Scribd.
And I'm Serge Martin, Senior Resident Solutions Architect at Databricks.
Today, we'll be talking about a few things. First, we'll review what a complex infrastructure can look like and some of the issues inherent with it. Next, we'll review the Terraform Databricks provider. We should note that we will be discussing using Terraform, but not what it is and how it works. For that, you can find other presentations and other guides elsewhere. Next, we will be discussing how this new Databricks provider has helped us solve a lot of our problems and issues at Scribd. And then finally, we'll talk about how the Databricks provider can help in a much more general sense. So again, I'm an SRE at Scribd, focused primarily on our data platform. I'm responsible for deploying our Databricks infrastructure to our data scientists, business users, and everything in between. And because of that, I kind of really enjoy working with like the big data technology, the collection of data, the processing, and all the analytical information that can be gleaned from it. And of course, outside of the office, I am a big fan of playing video games. Well, most notably, trying to get them to work on my Linux computer.
And I'm Serge. I am a lead maintainer of Databricks Terraform provider. So I worked in all stages of data lifecycle for the past 14 years, pre-sales, post-sales, implementation, solutioning, support, production, you name it. Like I built a couple of data science platforms literally from scratch. So I used to track cyber criminals through massively scaled forensics, and I used to build anti-PII analysis measures for payment industry. And yeah, here I help strategic customers of Databricks like Scribd to become more successful and bring them to the next level.
So what does a complex data infrastructure look like? So for example, you might have an array of different buckets that have all sorts of different individual use cases, types of data, all over the company. Next, you might have a few other like not bucket data stores like Kafka or some relational data store. Next, you'll probably have a few Databricks clusters that you use to access that data and process it to actually glean value. Of course, you'll have a number of roles and with those special access that those roles entail. All of the policy documents and rules and definitions that these roles need in order to have the access that they're supposed to have. And of course, on top of that, most of these are probably going to be in different accounts across the various different teams of an organization. Now, to focus in on a little bit of the complexities of running Databricks in this, with making Databricks changes in the web console, when people update various like config items such as worker counts, Spark context, or other various things, you can never really know where the changes were previously. All you know is the current values. You can't see what it was like maybe a month or a week ago, really. Additionally, like people can just go in and create and edit clusters that they have access to on a whim. Like there's no oversight, there's no checks or balances or anything. There's no real checks to make sure they're using the right tags that they need to, or this correct Spark context to get things working. And in large companies, it's kind of hard to make sure that everyone is adhering to like a sort of like written policy, but not like enforced policy, that things are being created correctly. So in order to kind of help maintain that, you have to reduce the number of people who can actually create clusters. So only a few people from like a team of like 50 can actually make the clusters. Which means that if someone needs changes to a cluster or needs a new cluster with some specific configuration items, an admin has to come in and actually build that for them with like a ticket or some message in Slack or some other way. And in doing so, they have to build it and often have to duplicate a lot of the config items manually. And then on top of that, with all this manual creation, as admins, we need to regularly go in and check to see if everyone is adhering to our like written policies and like standards of like, hey, are people creating clusters with the appropriate tags, with the appropriate departments, et cetera, et cetera. Then now Serge is going to tell us about what has solved a lot of these issues for us.
Yes, indeed, Hamilton. So we've created Databricks Labs Terraform provider to solve all of the before mentioned problems that large enterprises have to help people to unleash the power of Databricks automated jobs, streaming pipelines, workspace security, data security, and machine learning connected seamlessly with cloud storage, clouds, access controls, and networking through a tooling that's de facto is the industry standard for cloud native infrastructure. Because if you're running in a cloud, if you're running Databricks, then most likely you're using Terraform. Of course, there are a couple of other alternatives to Terraform, like CloudFormation or from Amazon Web Services or Azure Resource Manager templates, but still, they are not omni-cloud. They are not multi-clouds, and Terraform is the single tool that can have the similar syntax and the similar tool and the same tool for all of the clouds that you have, maintaining all of the things and breaching the gap. Basically, Terraform provider is working with almost any public API that Databricks exposes, and there is a resource for it in Terraform. Even though Terraform provider is currently not supported, it's still pretty actively used, and it has approximately 500,000 of downloads and more than 5,000 installs per day. We've been working in it for more than a year now, and it has 15 public releases and more than 50,000 lines of code with 83% code coverage and more than 600 closed issues. That's pretty impressive type of result. And many companies are using it for their production deployments. So what cool things does Scribd do with it?
So we've actually basically built out what amounts to an automated, deployable, distributed data mesh. So with even before the Databricks provider, we had already been building a lot of our various AWS infrastructure inside of Terraform. So with the new Databricks provider, we can actually start building this infrastructure out and then actually pushing it into Databricks automatically. Then with those new resources, such as like IAM profiles and other things living inside of Databricks now, we can actually start building clusters and other resources on top of these AWS resources, all automatically just with a few configuration lines, like whenever we need a new cluster, for example. And additionally, with using Terraform, we're able to modularize our building out of workspaces, our creation of inter-workspace objects, and keep them pretty identical between them and only change what needs to be changed to make them unique. So I'm going to take you through a little bit of code here, just to give you an idea of what it kind of looks like. So here we have a sample from a large map that we use to basically define all of our IAM profiles that we use inside of Databricks. So here we say, hey, we're going to create the profile core platform dev. It's going to need access to assume these roles in other accounts or other within the same account, but it needs to also assume these. It should have access to this set of secrets and be placed in this workspace with this group ownership. So once Terraform is run, our code will go through, create the role, create all the policies that allow for that role to get access to those accounts, attach those roles, grant all the policies to get access to the secrets it needs, and import it into the new Databricks workspace that it's required in. Following that, we actually have modules for creating the workspace themselves. So in this, we actually have, not pictured here, another map similar to the roles that define, hey, I want this workspace to exist. And then it comes down to here, calls the module for all of the different workspaces in the dev workspaces, and we'll iterate over that and just create us individual, nearly copycat, but uniquely addressable workspaces, just from taking a few AWS resources that are created outside of this. This way, if for some reason down the road, we have a new team join that say like needs super secret access to some special data that we don't want anyone else in the company for to have access to, we can just add a quick line and boom, we have a unique workspace already built out for them that we can just have them log in. So with that workspace that we have created now, now we have to fill it out with the various Databricks resources. So once we have the URL, we can go in and build out this. So what's not pictured here is the module that does this. It actually has like a bunch of files in it that have like lists of clusters and other things. But all it needs to get started is what environment we're in, what kind of like service admin accounts need to exist prior to integration with SSO, and what IAM profiles it needs. So in this module, we trim down all this extra code that we need to do to kind of like for downstream PR users, which I'll get to a little bit more. So rather than having them worry about the entire code base, like, oh, check this specific file in this massive Terraform stack, we can just say, hey, just go into this folder, and that's all of the configuration for the workspace that you want. And I'll want to point out that we're going to have a lot more details about this sort of code and this deployment process and all of what we do with this over at tech.scribd.com. Links will be provided. And as I mentioned with the PRs, well, we'll get into the PRs in just a moment. All of this Terraform code allows us to have like a single source of truth of what our infrastructure is, which being placed in GitHub gets all the benefits of any sort of like Git management system for a code base. We can provide an easy portal for teams that want to say, build a new cluster, make changes to a cluster, rather than the old way where they have to submit a ticket to me or like go into our Slack channel and be like, help, I need assistance. I need to change this from a 5 to a 10. They can actually just go into the code base and just submit a PR, and then we can pick it up in our normal PR review cycles, daily, weekly, whenever, and just get it approved. Additionally, with the Git setup, we can actually, what we've done is we've segmented some of the team's configuration items, like say a team like our applied research team has a dedicated cluster that's only for them, has their special sauce on it. And we want to lock down that a little bit more than just like access. So we can actually make them code owners of the files, the configuration files that configure their clusters. And in doing so, when any sort of PR or other thing gets submitted for those files, they're automatically involved in the PR process as a reviewer and approver on that. And that reduces the burden of all the approvals on us to the teams themselves a little bit. And further benefits of being in Git, we can leverage the sheer amount of like Git automation that's out there, such as GitHub Actions, to kind of trigger various different like checks and balances, linting, spell checks here and there, checking to see if it would actually run or apply. This way, like as the end users submit their PRs, they can get instant feedback on whether or not it actually works before we even have a moment to review it. And finally, one of the biggest and most beneficial reasons to put all of this infrastructure into Git, we get history of what's been happening. So we can look through the commit log to see exactly when a cluster got created, when a cluster got edited, who edited it, why they edit it because hopefully they left a description or a ticket or some reasoning for their changing the cluster creation sizes or whatnot. But we could, if there's an issue, we can easily look and see, hey, let's go talk to John Doe about this commit and see what he was thinking at the moment, or like what was the reason behind this. I'm happy to say that since rolling this out, we've actually been able to expand out the number of authors for issues and stuff from the 2 to 3 internal team members that have been working on this code base to a total of 13 across Scribd. Well, not many PRs with individuals, but the sheer number of individuals out there has been fantastic. This shows that there's not really as much of a bottleneck anymore on who has to do the code changes. So it really relieves the amount of work I need to be hand-holding on this. Now, with anything, there are a few risks and challenges with this. Now, with any sort of change management system or any sort of like PR or other thing, you're going to introduce a little bit of a slowdown with how fast you can make changes and edits to things. Whereas it'll take like 10 seconds to up the worker count inside of the console and call it a day and just be like, cool, we're good. You have to go through the full code review process with this to really get that pushed out. In the long run, we feel like that is an acceptable loss of time because you get to catch all of the cowboy like changes and before they actually start running rampant. And you can get a little bit of a communication involved in those changes. And it's not too hard to get the attention of someone who has the approval process to, okay, we need to get this done quickly. Let's hop on this and review and check very fast. Secondly, because we use a lot of private preview features with Databricks, or a lot of brand new features that are just came out like last week or like last month, we're trying to like do everything in Terraform, which means we tend to be on the absolute bleeding edge of the Terraform provider, which if anyone knows, being on the bleeding edge of any sort of software, you tend to run into like the edge cases first. So as Serge can mention a couple of times, like we've definitely had some bumps here and there, but nothing that was ever game breaking or like taking any of our systems down. More of just, oh, we have to account for this here and there. Speaking of Serge, what's the current version that people can get right now of the Databricks provider?
Right now, it's 0.3.3. It's 5th release, and we've introduced actually a feature of SQL permissions that helps to manage table access control across thousands of tables, across all of the workspaces you have from a single code base, which is coming for free if you use Terraform. You don't have to buy any other product. You just use Databricks with Terraform provider, and you have a fine-grained access control to your data objects. Isn't that awesome?
That's awesome. And that means I need to really hurry up and get on the sprint to upgrade that because I can't wait to play with that. And then finally, a big hurdle, but not one we foresee being much of one going forward. We've seen a little slow of an adoption of committing to Terraform changes, mostly compared to when we first released Databricks to our company. People went wild with creating clusters and like getting super excited about this and making all sorts of specialty single-use clusters. Whereas with this extra hurdle of the change management and needing to learn Terraform, people are a little bit more hesitant to just run rampant with it. But we don't expect this to be a huge barrier going forward, as we've invested a lot of time and effort into like internal documentation with like very detailed notes of, hey, this is what you want. This is kind of what you need to do, as well as with a few, many code examples in the code itself and extensive code review processes on request. So we'll actually pretty much pair with them on like, hey, this is exactly what you need to do. Here, here, and here. Oh, this is some funky thing with Terraform. You might want to check with this and make sure this works right. But with all these going forward, we don't really foresee this being a huge problem. Now, Serge, what do all these cool features that I've been happily playing with recently kind of mean a little bit more generally?
Well, Scribd was playing with the features of Terraform for more than 9 months now, from what I see, and you're one of the oldest users of Terraform, and you're one of the most versatile ones. So you're using almost it all. But basically, Scribd is doing what Martin Fowler-Block is calling a distributed data mesh. Distributed data mesh is inevitable for companies that have more than 50 people in the data team, and they want to let each team to build their own dataset and have their own journey without relying too much on other teams. Of course, they rely on a central team that's called data platform engineers, and data platform engineers are actually maintaining the whole infrastructure, usually with Databricks and Terraform, because if there is infrastructure in a cloud, there is Terraform. And this is not something new, so be prepared to hear this upcoming paradigm of distributed data mesh more and more often, just because martinfowler.com has written about it, and once something appears there, more and more people will start talking about it. So let's talk over a couple of real use cases of Terraform at a bit larger scale. So companies usually start with a job, a second job, a third job. They make like 20 different jobs that work with storage and mounts. Well, they work with it for a couple of months and they slowly bring that to production. And in production, they have to start adding permissions to their on-call teams and to their billing teams and to their business users, to shared auto-scaling clusters, and they have to control permissions. Otherwise, they're not compliant with security policies of their organization. And it becomes more fun when they are starting to add things like monitoring, audit logs, IP access control lists to this whole thing. Then they think, yeah, we actually should have automated this from the beginning. And they start automating it all with Terraform because they need to scale. Because suddenly they have to start thinking about the data locality rules in cases like their amount of data is so huge that they have to process that data within the region and transfer away only a processed delta table. So the cost of managing bigger infrastructure across 30 different workspaces is justified by network saving costs and regulatory costs. So this picture is not actually something that is quite unusual. We see some customers, both internal and external, that have more than 10 different workspaces. And sometimes their workspaces are all the same across 30 of the same kind, or they're a bit different per team workspace. So Terraform is actually enabling rolling these things out into production in a bit easier way. And this picture was just a simplification of the real thing that is actually used within Databricks internally for things like billing. And you have a call to action. Please explore Databricks Terraform Provider as the way to automate your entire infrastructure code review process and being able to recover from disasters and control the costs of your cloud spend and control security of your cloud spend in a reviewable way. Because if you grow more than 50 people in your tech team, you definitely need to adopt some production change advisory board type of methodology. And this is the best way to go with this.
Well, thank you very much for that, Serge. And again, my name is Hamilton. I work at Scribd, and I want to call out that we are hiring. So if you check us out, please do. Links will be in the chat. And Serge, I believe, isn't the Databricks provider completely open source?
Oh, yes, it's open source from the very beginning. We are looking for more contributors, always.
Well, definitely go out and check them out. And I believe Databricks is hiring as well, if I
Indeed,
do
we're
recall.
always hiring.
So again, thank you very much for coming to our talk, and have a great day.
Thank you, everyone.